Okay, let's look at this question. Okay, um, imagine there's a particle at a certain height. Okay, the height I'm not sure, and it is moving downward from point A all the way to point F. Okay, you can see here that's point F. Okay, yeah, that's F. Okay, um, before it reaches F, okay, it has to go through some sections. Okay, and the section looks like a staircase. Okay, imagine it's a staircase. Okay, and then the black dot is a particle. Imagine it's a particle that's moving down. Okay, from A it goes to B, B to C, C to D, D to E, and then E to F. Okay, B to C is a flat line. Okay, likewise D to E also a flat straight line. Okay, and then E to F. Okay, now what is given here is part A, the PE is given. Okay, potential energy is given. For part B, potential energy is given, and at D, potential energy is given. That's it. Okay, nothing else is given, and we are requested to find the rest of it. Okay, so the first question for part A, at A the potential energy is 50 joule. Okay, from there I can find out what is the height. Okay, so PE equals to mgh, and this is 50. M is 1 kg times by 10 times by h, and we can see that h equals to 5 meter. Okay, so h equals to 5 meter. So from there I can find out what is ke. Okay, ke is half times by mv square, but since it is not moving at A, it is not moving, at B it is moving. That's why you have like 3 lines just to indicate that it is moving. Okay, but at A it's not moving, so there's no V. Okay, so V is 0, so kinetic energy is also 0. Okay, ke is 0 joule, and there's no velocity, which is 0 meter per second. Now the next part, it has moved to part B, and P is given. It is given as 30 joule. Okay, so from here we can find that from 50 at a certain height, it has moved from part A to part B at a certain motion, and the due to the reduction of the height, the P is given as 70 potential energy. So what is our Ke? So we know Ke is 20. We know that, okay, conservation of energy, principle of energy mentioned that energy cannot be destroyed. It can only change form from one form to the other. Okay, so if P is 30, then there should be Ke. Why there's Ke, kinetic energy? Because there's motion. Okay, that's moved from A to B. So from here we can figure out what is VE. So Ke formula is half times by mv square. So half times by 1 times by v square equals to 20. So v square equals to square root of 40, and the answer is 6.3 meter per second. Okay, so that's for part B. And what happened at part C? Okay, it's on the same level field. Okay, it's on the same level field. Is there any potential energy? Yes, certainly. Since there's no, it's only moving horizontally, there's no movement, there's no change in height, then PE remains as 30 joule, and KE is 20 joule. So therefore VE is also V equals to 6.3 meter per second velocity. Okay, now P is for section D. P is given as 10 joule. Okay, you see from C it has gone down to D, so again a reduction of height. When there's a reduction of height, of course the potential energy will not be the same, it will be reduced as well. So if PE is 10 joule, what is KE? So KE equals to 40 joule. Okay, KE equals to 40 joule. So KE equals to half mv square. So half mv square equals to 40. So m equals to 1. So v square equals to square root of 80. And the answer is 8.9 meter per second. So what happened at E? Again, it's on the same line. Okay, a level field. So it hasn't moved downwards, so it's on the same line. So PE again equals to 10 joule and KE will be 40 joule. Okay, so V equals to 8.9 meter per second. Now at F, okay, it has gone from E to F. F is the level, it's the lowest level, okay, at the surface. So it has gone to the ground level, F. So what happened? Will there be any potential energy? No, there won't be any potential energy. Okay, remember, F is the ground. Okay, it has gone to the ground. So from A it goes to G is also same level with F. So PE equals to 0 joule. If P is 0 joule and since F is still moving, so KE should be 50 joule. If KE is 50, so from here we can find out that what is the velocity. So velocity equals to half times by mv square equals to 50. So m equals to 1, so v square equals to 100, therefore v equals to square root of 100, which is 10 meter per second. Okay, now let's look at G. At G, imagine that A is just falling down, okay, downward, and reaching D instead of going through the staircase or the steps. Okay, so at A we can still find out at A V equals to 0 meter per second. Okay, and then m is 1, we don't need that. We can use Survet formula to find out. We already know the height is 5. Okay, so s equals to 5m, u equals to 0, so initial, so u equals to 0, and we know a equals to 10 meter per second square. So that's the acceleration due to gravity. So therefore v square equals to u square plus 2s. So v equals to u square plus 2as. So v equals to 0 square plus 2 times 10 times by 5, and this is 2 times 10, which is 20. 20 times 5, 100, and you see that you are getting the same answer as in at F.